Hello everyone, in this video I'll explain how we can use a priori algorithm for finding frequent data items. So basically this algorithm analyzes a data set to determine which combination of items occur together frequently. So basically frequent item set are items that have minimum support. So here in this particular problem the minimum support is given as 50% and the confidence is also given as 50%, and we are supposed to find the frequent item sets and the association rule using a priori algorithm. So here for transaction we can see the transaction IDs 2000, 1000, 4000 and 5000, and the items bought are also given here A, B, C, A, C. So in for the transaction ID 2000 we can see that the items brought are A, B and C. For the transaction ID 1000, we can see the items brought are A and C. For the transaction ID 4000, we can see the items brought are A and D. For 5000, it is B, E and F. So we have all these transactions and various items bought. So our objective is to find the frequent item set from this given transactions. So how we can find it out? So basically what we have to do is since the support is given as 50%, that means that we need to find the items which is having a minimum support of 50%. So how many transactions are here? So we have one here, one, this is 1, 2, 3, 4. So 4 transactions are there. So minimum support 50% means, so out of this 4, 50% of 4 is 2. So we have 2 as the minimum support from this transactions. So basically it should satisfy this minimum support 50% and confidence also 50% it should satisfy. So now from the given set from this transactions, what we can do is we have to scan this one. So which all items are brought from this transaction? You can see all this when you scan through this data items, you can see that A, B, C, then D, E, F are the items which are all bought in during this transactions. Okay, so what we have to do is now we will be finding each set. So we have A, then we have B, C, D, E and F. So we will be seeing how many times these items are purchased. So first let us consider each item one by one. So instead of A, B, C, D, E, F, we'll be considering items A. So how many times A is purchased? So we can see here 1, 2, 3. So 3 times. And how many times B purchase? It is 1, 2. Then C, it is 1, 2. Then D is 1, E is 1, F is 1. So similarly, you can find, you have to write all those values here. So we have to form the set and we have to write the support. So A, the support is 3. B is 2, C is, so how many times it is appearing in the transaction we have found like a single item set. So the first thing is we need to find the frequency of occurrence of the single item. So now we can see here A is 3, B is 2, C is 2, D is 1, E is 1, F 1. So once this table is done, the next step is to you need to check whether which all items are satisfying the minimum support of 50%, because it is given in the question, it should satisfy minimum support of 50%. So minimum support of 50%, as I said, there are 4 transactions. So 50% of 4 is 2. So at least in 2 transactions this single item should be present. That is what is meant by this minimum support of 50%. So here A is 3 means it is satisfied, B is 2 means it is satisfied, C is 2 means it is satisfied. But this 3 items are having a support of 1 only, but it is not satisfying that 50%. So we don't consider this 3 items. So now from the first set we have shortlisted the items which can occur frequently, A, B, C. That is for the single item set. Now what we have to do is, okay, this is what the single item set we have found which is occurring frequently. Now we have to generate the second set, because first in the first step what we have done is from all the transactions and the items purchased we have considered single item set. Now what we do is, now we have seen, we have from all this 6 items, A, B, C, D, E, F, we have found that only this 3 are satisfying the minimum support. So now out of this 3 items, what we do is we'll be taking 2 combinations. So A, B, C will be taking 2 combinations at a time and we'll be finding the support again. So from A, B, C we can have the combination A, B, then we can have the combination AC, then we have one more combination BC. So this 2 item set we need to check in the original table how many times it is coming. It is occurring. So we have AB. AB is occurring 1. Then we have AC. AC is occurring twice. Then BC was the last one. So BC is occurring 1 time. So we can just have here how many times this is occurring. So AB is occurring 1. Then AC is occurring 2, BC is occurring 1. So now this one actually this is not satisfying not satisfying the minimum support. This is also not satisfying. Only this is satisfying the minimum support. So what we have to do is in the next step we will be checking for the support and we'll be taking out the item which is satisfying the minimum support criteria. So we know that here the set AC is satisfying the minimum support. So that is being taken. Now what we have to do is now the data contain frequent item AC. Now we can have suppose only AC is there, so only 2 item set. So that is the final one you can see here, because we can't go for 3 item set because AC is 2 elements are there. So now we can have here, so 80 AC is the frequent item set according to, because it is satisfying the minimum support criteria. So AC is frequent item set. Now how we can form this association rule is because AC is the item set, frequent item set. So we can have the association rule like this, A to C, and from AC we can write it as A to C and C to A. So this two are the association rule. Even when you are writing the association rule, you have to find the confidence because in the question it is given that it should have a minimum confidence of 50%. So if this any of this rule doesn't have a minimum 50%, then we won't be able to consider that association rule. So let us consider this A to C association rule. We already know that it is having a minimum support of 2 because here we have already found it, the support is 2. So A to C and C to A, the support is 2. We already know about it. Now we will see the confidence. How will you find the confidence of this one? Association rule A to C. So the association rule A to C, the confidence is nothing but it is A union C divided by A. So what we have to do is A union C divided by A means from the set we need to find, from the data set given transaction, you need to find how many transactions are having both A and C. That is in the numerator. Numerator A union C means both A and C. So we need to find the transactions which is having both A and C divided by the transactions which is having only A. So we will go and see here now the original table. We will see how many transactions are having A and C. So we can see that this transaction 1 is having A and C, and here in transaction 2 is also having A and C, and our association rule is A to C. So for the association rule A to C, we know that it is A union C divided by A. So A is how many times it is coming. So here 1, 2, 3 times. So A union C is like A union C, both A and C appearing is 2 times. In two transactions we are having A and C. So numerator will be 2 divided by the number of times A is occurring. So A is 3. 1, 2, 3. You can see 3. So the confidence level of the association rule A to C is 2 by 3. So that is what we can see here, the confidence level. We have to find the confidence level A union C divided by A, that is 2 by 3, that is 0.66. So when you convert into percentage, it will be multiplied by 100. So you are getting it as 66%. Similarly, you need to find the confidence level for the association rule C to A. So C to A is C union A divided by C. That means the number of transaction having both A and C and divided by the number of transaction having only C. So A and C we have just now we found it. It is 2 and Let us go here and we need to find C to A. Association rule is C to A. That means C union A divided by C. So how many times C and A is present? 2 times. So it is 2 divided by how many times C is present. So here C is present 2 transactions. So it is 2 divided by 2. So we'll be getting 2 divided by 2. So the confidence level of the association rule C to A is 2 by 2. So you can see here we have 2 by 2, that is equal to 1. So 1 into 100, you got it as 100%. So from the frequent item set, we found this one A and C other, the set AC, that is the items A and C are purchased together. That is a more frequent item. And we found that the confidence level of association rule A to C is 66% and C to A is 100%. And as per our question, the minimum confidence level should be 50%. That means both the association rule A to C and C to A are satisfying this condition. That is the minimum confidence of 50%. That means we can take both the rules. So the final output will be the association rules will be A to C and C to A. Why both the association rule has been taken? Because it is satisfying the confidence level, minimum confidence level of 50%. So this is how we can use a priori algorithm to find frequent data item set. Just once again, I'll just go through this one. So what we have to do is first we have to see the transactions, and if any support or confidence is given like this, then you have to find 50% means how many transactions are there out of that 50%. 4 transactions, so 50% of that is 2. So at least in 2 transactions this frequent items should be there. That is what it is meant by. So items brought here is A, B, C, D, E, F. So total items, what we have to do is first we have to find the frequent item by taking finding the support by taking one item at a time, and then we'll be taking only those items which is satisfying the minimum support. So this is what we have got. Then we will be taking 2 items at a time, and then again we'll be finding the support, and then the items which is satisfying that support only will be taking. So here we have taken only one. So we have got it as this as the frequent item set. So once the frequent item set is done, we can generate the association rule. So here A to C, so we have A to C and C to A, we have taken it, and we need to check the confidence level of each association rule, and if it is satisfying the minimum confidence level, then you can take both the association rule. So suppose the support is not given, we can find the support by using this formula. Support is like A union C. Suppose the rule is like this: support, if you want to find A to C, how will you find this? A union C. That means you need to find the transactions, the number of transactions where both A and C are present, divided by the total tuples, means the total transaction. In our case, A and C is present in 2 transactions, so it will be 2 divided by, I suppose it was 5 transactions are there total, 5 or 4. So we'll be dividing that with the total tuples. So that total tuples in numerator it will be A union C and divided by the total tuples. This is how we'll be finding the support. So this is how we can find the frequent item set using the a priori algorithm. I hope you understood how to use a priori algorithm for finding this one. Thank you all. Thank you.